Welcome to another episode of Clean Critically. Today, we will talk about Legos and maybe atoms. These are excellent ideas for manufacturers brought to you by the product quality cleaning workshop teachers of Darren Williams, Ed Koenigsberg, and I'm Barbara Koenigsberg.
And here's our contact information. We all do work for industry, improving cleaning processes. And so reach out to us with your questions.
And we all love to teach. So by all means, ask questions.
So today we're talking about elements and atoms. An element is a pure substance. It has specific properties. The atom is the smallest unit of an element that retains those properties.
And as we've learned more about atoms, we've discovered that there's even smaller particles that make up the atom. These are familiar to most of us, the proton, the neutron, and the electron. So let's talk about these briefly. So protons and neutrons are at the center. They are what we call the nucleus, or form the nucleus of the atom. And the electrons surround that nucleus. And then there's also charge associated with some of these particles. So we have the proton, which is charged positive, the electron, which has a negative charge, and then we have the neutrons, which exhibit no charge. And so you can see this common chemistry joke. And so the bartender says for the neutron, no charge.
Oh, funny.
Yes. And so then we also have this dynamic of opposites attracting. So the electrons and the protons are attracted to each other. And then we also have similar charges repelling. The protons repel other protons and the electrons repel other electrons. And this charge is important in the substance of the atom, the element, even the molecules, and even in our cleaning processes. The different charges in a molecule and in the soils and in the surfaces can really impact how well something cleans.
It's true.
Now, to keep track of all of these numbers, the neutrons, the protons, the charge, we have this atomic symbol notation. So we'll go through this briefly. This is a method for accounting for all of those different particles in the atom. So in this particular case, for this oxygen, we have this 16, which is the mass number. And that is the sum of the protons and the neutrons. So we could figure out that this is all of the heaviest particles in an atom, so it's approximately the mass of the atom. So if you look at a periodic table and you see oxygen, you'll see that its mass is close to 16. It's like 15.998. And then the atomic number is the number of protons. So oxygen has 8 protons. And if you wanted to know the number of neutrons, you would just take the difference between those two numbers. Subtract 8 from 16 and you get 8. So it has 8 neutrons in this particular isotope of oxygen. And we'll talk about isotopes in a minute. The letter O is the elemental symbol. Now that word symbol, it doesn't look like a symbol, it looks like an alphabetical letter. But if you saw that table at the beginning of our video, those were the symbols that the alchemists were using as they were trying to come up with a recipe to make gold. And it was their encryption, it was their shorthand. And so they could make their notes, and if you didn't know what the symbols meant, then you couldn't read their recipe. So we kept that in chemistry, that name symbol for our atomic elements. And so this is determined by the atomic number. You can see a different letter for each spot on the periodic table. Each different number of protons gives you a different elemental symbol. And then you have the atomic charge. This is just the difference between the protons and the electrons. So if you want to know the number of electrons, you could subtract that atomic charge from the atomic number or number of protons, and you get the number of electrons. And so in this case, this particular oxygen has 10 electrons, 2 more than the protons, so it shows a -2 charge.
So I'm going to emphasize that the protons determine the element. Hydrogen has 1 proton. Helium has 2 protons. And that's all it is. It's the proton names the element. But what about isotopes?
Yes, so isotopes are the same element, but just different number of neutrons. And so here we're showing 3 different isotopes of carbon. And so they have different mass numbers because they have different numbers of neutrons, but they have the same number of protons. That's what makes them carbon. And so we would call this top one carbon 12 and carbon 13 and carbon 14. If you don't list any of these numbers, then we just assume a mixture of the natural abundance. So carbon naturally here on Earth would be 99% carbon 12 and 1% carbon 13. So if you just see a C, then it's assumed that it has this ratio of 99:1 of the different isotopes.
But the C is a mixture.
That's
It's
right.
not.
Yeah.
And I think it's important to understand that you can hug a tree, but you really can't see an electron. And back in the day, I guess the 50s, 60s, the mid-century modern old school concept was that the electrons whirled around the nucleus, kind of like planets. And no, that's not the way we look at it today.
That's right. Today, it's the wave nature of the electron that keeps it out of the nucleus. And so it really is like an oscillating electron cloud. And this is the actual, the function that we're talking about with this electron cloud of it vibrating around the nucleus. And that's the wave-like properties of the electron.
And this concept recognizes our evolving concept of what stuff in the universe is like. Okay, let's yeah, go ahead.
So we have to organize the atoms because atoms are all made of the same building blocks of protons, neutrons, and electrons.
And there are subatomic
There's other
particles.
stuff
That's right.
that make up the protons and neutrons and electrons, but we're not getting into that.
Right, quarks and gluons and all that.
Yeah.
Muons and oh boy.
There's a large assortment of elements. In fact, currently we can name 118. So you can think of them as balls of different colors, or an ingredients list.
Or Legos. We
That's
like that.
right.
Now, this is a page that we pulled out of Ed's high school chemistry text. No, actually,
No.
it was a table of the elements in 1671, 2 centuries before the modern concept of atoms. And you can see that there are allusions to planets, and we've got elements mixed in with molecules. We've got a whole bunch of stuff going on there. But the point is, it was the way things were understood.
It's the way we understood stuff.
Yes.
When you were in high school. Yeah.
Right. Yes.
Here is the ultimate, right? The way we understand it right now, or approximately right now. Darren, would you like to discuss?
Yes. And so this is really amazing. 118 elements, and really sort of naturally occurring elements kind of stop around uranium at 92. And yet we can build all of the things in the universe with just these essentially 92 or 118 different building blocks. You can compare this to Legos. Think of all the things you can build with Legos, and it takes 3,700 different types of Lego bricks to build those things. And we can build even more things with our 118 elements. I mean, think of the amazing diversity of things in the universe and processes and reactions. It's amazing and mind-boggling to think that the versatility of these 118 elements can build everything that we've seen.
Yeah, and some of those are so unstable that they only exist for fractions of a second.
That's right. Yeah.
They're very
really
important.
only the 92 more stable ones.
Yes.
And even some of those are not totally stable.
That's right.
Which is what we call radioactivity.
And this is the way we picture them. This is the way we conceptualize them. Next. A little word sponsors. We're sponsoring ourselves.
That's right.
If you would like to learn more about aqueous cleaning, which aqueous cleaners are made of molecules,
That's
We would
right.
like to introduce you to our aqueous cleaning on-demand course. We've heard it described as more fun than a bubble bath, very informative. Teach yourselves, teach the folks who are doing the assembly. It's education. You get continuing education credit. It's fun. You get some time to talk to one of us, and it's favorably priced.
That's right.
So moving forward,
Yeah, we want you to get comfortable with elements and with atoms and this idea of them being building blocks, because then they build up to molecules and compounds and mixtures, which is what we're going to discuss in our next video. So we can't really talk about the molecular nature of cleaners or solvents and so on if you're uncomfortable with the idea of atoms making those molecules. So that's why we did this very ground level video on atoms, and next we'll talk about molecules and mixtures.
and here's how to reach us. And here we are. Here we are. You know how to reach us. We want to continue to bring you excellent ideas so that you can clean critically. Till next time.
Yes.